Okay, here this is a CSEC E test quiz for technical drawing. First question: in an isometric sketch circle, an arc will appear as part of an ellipse. This part of an ellipse. Question number 2. Which of the following instrument is used to draw irregular curves? That is flex curve. A compass is used to draw arcs and circles. A protractor is used to draw angles. Radius curve, not sure what that is, but a flex curve is used to draw arcs. Which of the following drawing shows a triangle of equal area between parallel lines? So this is the correct answer. The rule states that any triangle that is formed within the same altitude and at the same base has the same area. Say, for example, this triangle. Once the base is the same and the altitude, it has the same area. It means therefore that this triangle has the same area as triangle MON or MPN. Item refers to the following diagram. In the drawing above, which of the following letters indicate the center of the arc which is tangential to two circles? That is O. So O is the center of both circles. And we generate this by subtracting the radius, subtract the radius 3 from this radius. So we subtract this radius from that radius, use that to draw an arc. Oh, see here, R, big R, subtract small r. R5 subtract radius of this. What we get, the use that to draw an arc, where both centers meet is the center for the arc. We then readjust our compass to the original radius to draw that arc. The item refers to the following views. Which of the view below shows the plan of the object illustrated in the two views above? So here, to represent this into a three-dimensional figure, this would look something like this. That's basically how that looks. So the plan, so we would have this, and out here. So this is going with so far this, but this has it has broken lines inside here to represent the circle. But this one doesn't contain the broken line. So that could not be it. So this, based on this, this would be the correct response. This would be the correct response. So far, yes. So this has that an outline, and then it has we have this edge, 1, 2, 3, 4 edges. 1, 2, 3. Let's see. All right, let me sketch the plan for this and then see which one matches that. That's the best way to do it. So sketch that plan first. So we'd have something looking like this. So this line would be here. All right, so this would be here. These two edges would be here. One here to represent this edge. Another one here to represent this edge. And the third one here to represent that edge. This will be represented by this. Have another one here, this for this. We have that. This is represented by this edge. And we have this, which seems to be in line with that. So we'd have this broken line coming down here for this side. So this seems to be as a broken line, which seems to be somewhere there. That would be the broken line for that. Let's now see which one looks close to that. Which one looks closer? So we have 1, 2, 3, 4, 5, 6, 9. So this seems to be the correct one. Let's move on to another question. Which of the following correctly defines the locus of a point? Based on the responses, a point which moves and traces a path, which would be this. All right. So locus basically is, say for example, you have a wheel here. This wheel, this circle rotates along a flat path here. As this point moves around, it would create a pattern. So as this roll, that point would move around to create a pattern. So this would be the locus, the path traced or created by a pattern, created by a point to form a pattern. So this, in a sense, this particular locus would be a cycloid. Of course, we have other types. Which of the following circles is correctly dimensioned? Right. It's important to note that this question has two possible answers. Be that for traditional drawing with AutoCAD, there's a feature, well, this is incorrect. This one is definitely incorrect. This one has a diameter sign on this here. So this is the possible correct response. This could be, well, in AutoCAD, there's a form of dimensioning which is consistent with this one. So this could possibly be, well, no, but there's no radius sign on this. So this, no, this is incorrect also. There's no radius sign there. So, oh, this one has a radius. So there could possibly be two answers for this one. So this could be questioned because in AutoCAD there's ISO setting. You have ISO setting, and we have this other setting, dimension and style, which that which dimension object similar to this one. So this has two possible answers. But this could be one answer. If you're speaking to traditional drawing, this would not be the correct response. You would want a line coming from the center here. A line coming from the center there for that. And we would label this like that for traditional drawing. But be that we are now moving on into, we have now moved on to AutoCAD. This and that one are possible correct responses. So I would say this has two possible correct responses. But based on the fact that CSEC hasn't fully transformed to AutoCAD, I would probably use wisdom and stick and choose that one. But technically, D could be correct also. Item refers to the following diagram. The polygon shown above is a regular hexagon of sides in this case, for a six-sided figure, to draw a circle, to draw a hexagon, we would use the radius. We would open our compass to the radius, and we'd use that distance to draw a circle. Yes, it means therefore that the radius would be each side, the side would be the same distance as the radius for a hexagon. It means therefore that if the diameter is 95, then it's 95, then the radius would be half of this. So we would divide this into two. 95 divided by 2 is 45 plus 2.5 is 47.5. So it would be this one. So this pretty much follows the basic principle of constructing a hexagon when giving the length of one side. We would open our compass to that one to the length of that side, then draw a circle. We would then use that very same radius to mark six equal increments on the circumference. This item refers to the following diagram. The triangle illustrated above can be constructed with the use of for this example, you would need only, so this is drawing a triangle when giving the length of two sides and the included angle. So you would need simply a ruler and a compass. You can construct the 75 degrees, so you don't necessarily need a protractor. So you would need either a ruler and a compass. Of course, you need pencil as well. So you need a compass, a ruler, a compass, a ruler, and a pencil. Or you don't need set square and ruler and a protractor. Well, this couldn't work. You need something to draw with, to mark on the paper. Compass and protractor only cannot work. Ruler and pencil alone cannot work. You would need something to construct the angle. So only the best response here would be C. That would be correct response. Which of the following is a view of a right angle pyramid? This would be right angle pyramid. Right angle pyramid. Remember, a pyramid, the side slopes in, or they meet at a point you call the vertex. So this would be the correct response. Which of the following represents the correct procedure for bisecting an angle of 90 degrees? So the correct response is this one. So you would first construct your 90-degree, then you would place your compass here at this point, scribe this first arc here, then you'd place it here, scribe the second arc to get that 90. The item refers to the following diagram. Which of the following represents the plan of the drawing above? Okay, so let us analyze this. So here, this edge, this would look something like, let me sketch this first, then see which one corresponds to that. It should be that. We have here, seems to be, well, you couldn't tell if it's taper. Let me see the response. Well, here we'd have a broken line here. So anyone that has a broken line here is one to feature. One broken line here, a second broken line here to represent one broken line here, second broken line here. We would also have a broken line here, two broken line here to represent this. So this could not be the correct one because this has only one parallel broken line. So this has two for the whole here we would need two broken lines to represent that. Let's see what's the other option. This is pretty much out, this is out. So the correct response by elimination would be this one. Which of the following patterns would be folded to form a truncated square prism having no cover or base? So truncated prism would look something like a truncated square prism would look something like this. That's not so straight. This would be the regular. When we cut that, once we, for to cut this here, cut this along here, create a truncated section. This would look something like so we have four sides. One side would look something like this. So 1, 2, 3, 4. One side would look something like this. This side, the other side would look something like this. It would then go back down to that. Then it would go back to that. So this is basically how that would look. So anyone that looks like that, so far I think this would be it, except that this section would be, this part would be, yeah, so this would have been it. This has a cut at a different location, and so would have been this one. Each of the following diagrams shows a rectangle equal in area to a triangle. A rectangle equal in area to a triangle. That would be this one here. So the rule states that this would be it. Why this is correct? The rule for generating that would be to, how do we do that? We would draw the triangle. We would first draw the triangle. This would be the triangle. We would then draw a line through the vertex and bisect this. Midway of this distance, bisect this, find a midpoint. Then we draw a line through here. Then bring this up. So the width of this should be half this distance. And this side should go up, touch that bisector. So this would be the correct response. Item refers to the following views. Which pictorial view below is represented by the orthographic view shown above? All right, so we have let's look at all of them. So this, I think this has a curve edge up there, curve. This is broken. All right. So this is out. This one is out. This is out. This one, this seems to be it. This seems to be it. Yes, so this is out also. Yeah, this is it. This one is it. This is it. This item refers to the following construction. There seems to be a tangent from a point P outside a circle. This seems to be a tangent from a point P outside a circle. Draw a tangent to a circle from A. Well, yes, that is it. First one. Draw a tangent to the circle from B, now from A. So that's the correct response. We don't need to go any further. So this is basically the same thing. Well, pretty much similar to what we had. This is pretty much the same thing. The item refers to the following diagram. Again, this seems to be a tangent. Item refers to the following diagram. In the diagram above, the angle EFH is it's 90 degrees. It's 90 degrees. It's 90 degrees. 90. The rule states that any triangle that is formed in a semicircle, the angle is always 90 degrees. So very important. So if it was from here to there, this would have also been 90. So that's the fundamental rule. Any triangle that is formed within a semicircle, once the base of the triangle is the same as the diameter of the circle, the angle formed is always 90 degrees. Very important. So that is 90. A cube with an edge of 80 millimeters is to be drawn in oblique projection. The length of the receding line in millimeter should be 40. But the rule states that when you're drawing oblique, you normally use half the length of the given distance on the oblique side. Say, for example, this is the cube that we want to draw. Yeah? The rule states that you normally use half the actual length. Be that oblique 10 to, if you were to use, say this is 40 by 40, if you were to use a full 40 here, it will look too long. So the rule states that you use half the actual measurement given, but you label it as full. Yeah? Say for example, this is, in this case, this is 80, 80 by 80, 80 by 80. You would actually draw this side 40. Draw the side 40, but you will still label it as 80. Yeah? So this is the correct response. This item refers to the following diagram. Which of the following is a true elevation of the drawing shown below? True elevation. All right, so here, all right, so this elevation seems, this is one elevation, this one seems correct. You have this here, you have the L right here, you have this down here. This one seems correct so far. This one, you have that, you have that, and you have that. Now for this one, here shouldn't have been there. This one, this section shouldn't be there. That shouldn't have been there. So that's it. That's an error on that one. So based on that, I could pretty much stop right there. This is the true elevation. Which of the following illustrates the normal of an ellipse? The normal. And we here, so we find the normal by first finding the focal points, then join the focal points to the point where we want tangent to be. And from that, we bisect the angle formed between those 2 points. The bisector, the angle that is formed between focal point 1, the tangential point, and F2 is the normal. So F1, the tangent, the point, and F2 forms an angle. Yeah? When we bisect that angle, this becomes the normal. So the normal is the bisector for the angle that is formed between F1 point, tangent point, and F2. The spiral of Archimedes is defined as the locus, in this case. So the locus is basically, we have a point here, and this revolves uniformly from a particular distance over to that point. So the best response here would be this one: the path generated by a point which revolves uniformly about a pole and has a uniform motion away from it. So this would be the best response. Which of the following pattern can be folded to form a square prism with an oblique top? Oblique. Which of the following pattern can be folded to form a square prism with an oblique top. This will give you a square top. This, I think this one. So this, item refers to the following diagram. The diagram above illustrates the construction of a. This is pretty much how to construct an arc two line of a given radius. Circle tangential to two, tangent to form circle tangential to two lines at right angle. Yes, this is it. Circle arc. Well, in this case, it will be an arc. Circle tangential to two circles at right angle. Well, let me see. Tangent to a circle at a point on the circumference. Circle tangential to two converging lines. Not just converging, but tangent from a point. Oh no, this is wrong. Circle tangential to two lines at right angle. Yeah, this is it. That is it. This item refers to the following diagram. To the construction using the design and bending G illustrates above. This is tangent to two unequal circles. Yeah, tangent to two unequal circles. Yeah. The point at which the bisector of an angle of a triangle meets is the center of. So the point at which the bisector of an angle of a triangle meets is the all right. So for this one, we have this. Yeah. So the point at which the bisector of the angles of a triangle meets is the center of an inscribed circle. So you'd bisect these two angles, bisect one angle there, bisect a second angle. Point where they meet is a center for an inscribed circle. Yeah, so the answer would be this one. This item refers to the following diagram. The type of projection illustrated above seems to be an oblique. We have one side flat, one side at an angle. So this seems to be an oblique projection. So the following is true of the construction above. Well, the square is equal in area to the rectangle. All right, so EFGH is equal area to IJK. EFGH is equal in area to IJK. Yeah, so this will be the correct one. ANSI National standard. When sketching pictorial figures, one should first sketch circle, draw all straight lines, construct parts separately, construct a box to hold the figure. Yeah, definitely. You have to construct a box to contain the figure or to hold the figure. That's the first thing. Construct a box first. Then remove what you don't want. Yeah. I'm using a new mouse. This mouse needs some getting used to. So we construct a box to hold the figure. Then we cut out exactly what we don't want or what we want. Next question. Which of the following surfaces is developed in the shape of a T by unfolding or unrolling into a T? That would be prism, rectangular. Which one is it? Square, 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 square. Into a T. So let's have four sides and top and bottom. Square, square, not square. It should be square, triangular prism. No, this T. A rectangular box with, oh yeah, a rectangular box with lid. Yeah, rectangular box with lid, definitely. So this would have been the box. So when this is unfolded, it will look something like this. One side, and the lid would be here on one side, one lid at the top, one lid at the bottom. So we would fold this together. This would be the top, this would be the bottom. The construction above shows how to draw a parallelogram equal in area to a given triangle. If EF is 30, then X is, EF is 30, then X is 15, which is half the altitude. So it should be 15, half the altitude. Diagram above shows the method of finding the center of an arc with radius r, which is tangential to two straight lines meeting at right angle, two straight lines meeting at an angle. Yeah, listen, two straight lines meeting at an angle. Definitely this one. The diagram above is to be reproduced in third angle projection. On which view can the distance x be seen? So x can be seen on the plan and also on the end elevation. Plan and top view and right side, top view and left. We can see a top view, top and left. Well, or on the top and right side, not the front. This is the front elevation here. This is the top view. So it can be seen either on the right hand side or on the left hand side. So the top on the right hand side, top on the, yes, that on the right hand side, yeah. The sides of the square QRST above are bisected, and the adjacent points are joined to form another square. The area of the new shape is, I think this is half the area of that. 1, 2, yeah, this is half. So the area of that would be that would be 81. Well, I'm not sure that one. Let me go through that one more time. Okay, so we have 1, 2, 3, 4. The internal square has 1, 2, 3, 4 parts, while the external part has 4, 5, 6, 7, 8. So 4 over 8 would be 1 over 2, which would be half. So this would be half the area. And if the area of this is so 80 by 80 by 18 by 18 is what? 324. Divide 324 into 2, we get 162. So the area for this would be 162. In terms of maths. In the diagram above, circle and curves are shown in their true shape. The method of projection used is it's not oblique. This is not iso to be also is a two-dimensional view. So this and this doesn't look isometric. This should, if it is isometric, this would have been oval. It is, well, for oblique, you have cavalier, you have both cavalier, and you have cavalier, and you have the, what's the other one again? Where one is drawn at the full length and the other one is drawn at a reduced length. So it's not orthographic because it is three-dimensional. Let me figure this out a little bit. I am not sure about this one. I'll need to look a little bit more detail. Look in a little more details on this one. FC1 plus FC in the ellipse above, with sum of distance is equal to AB. FC1 plus FC2. Yeah. Mm-mm.